All right, so change of base formula. We're going to change to base B from base A. All right, so we're starting off with y. We're starting off with y being equal to log to the base A of x. So what we're going to do is that we're going to change from log A to the base A to log to the base B. And in so doing, we're going to come up with a change of base formula. All right, so this is log form. The log to the base A of x is equal to y. So in index form, it is the number x is equal to the base A raised to the power y. So I just move from what? Log form to index form. Now let's change the base on both. Let's change the base now. Take log to the base B of both sides. So now log to the base B of x is equal to y log to the base B of A. Now, if I divide both sides by log to the base B of A, I'm going to get, this cancels that. I'm going to get y is equal to log. So remember y, which is what? Log to the base A of x is equal to log to the base B of x divided by log to the base B of A. All right. So let me write that over to the right. It seems like we're sort of forcing it at the bottom.
Jadon?
So I was sort of erasing this to say I was going to write it at the top. All right, so what we have is if we divide both sides by log to the base B of A, we're going to get y, which is log to the base A of x is equal to log to the base B of what? X divide by log to the base B of A. Now, this statement here, this is your change of base formula. That is your change of base formula. That log to the base A of x, changing from log A to log B, is equal to log to the base B of x divided by log to the base B of A. That's called a change of base formula. Now, if x is equal to b, we're going to get what? Y, which is log to the base a of b, is equal to log, changing log to the base b of b over log to the base b of a. But log to the base b of b is what? 1. So this is 1 over log to the base b of a. So log to the base a of b is the same as saying 1 over log to the base b of a. It's sort of like you're interchanging the bases. Let us see if we can apply. So this is your change of base formula. And let us see if we can apply this now to a question. All right, example 48 says solve the equation log to the base 2 of x is equal to 4 log to the base x of 2. All right, so in this case, the log on both sides are different. I think life would be a lot simpler if the base on both sides was the same. So working with the right-hand side, this is the same as saying log to the base x of 2 to the 4, which is the same as saying log to the base x of 16. Now, changing the base from log to the base x to log to the base 2. So log to the base 2 of x, left-hand side, is equal to, using our change of base formula, log to the base 2 of 16 over log to the base 2 of x. Now, 16 is the same as saying 2 to the 4. So this is the same as saying log to the base 2 of 2 to the 4 over log to the base 2 of x. Now, if you bring the 4 to the front, you're going to have what? 4 log to the base 2 of 2 over log to the base 2 of x. And this is log to the base 2 of x. Now, log to the base 2 of 2 is 1. So we're going to have log to the base 2 of x is equal to 4 over log to the base 2 of x. Now, if I have one fraction is equal to one fraction and I want to get rid of the fraction, I would cross multiply. So we have log to the base 2 of x times log to the base 2 of x. So this is log to the base 2 of x squared, because you multiply it by itself, is equal to 1 times 4, which is 4. Now, I'm going to what? Find the square root. The opposite of square is square root. So log to the base 2 of x is equal to the square root of 4, which is positive or negative 2. So now what we have is log to the base 2 of x is equal to 2, or log to the base 2 of x is equal to minus 2. Our objective is to find out what x is. Now moving from log form to index form, we get x is equal to 2, which is the base, to the 2, or x is equal to 2 to the minus 2. So therefore, x is equal to 4, or x is equal to 1 over 2 squared, which is equal to a quarter.